Hello guys, we are moving on with surface area for math and 6. So we'll try to handle this problem which says to calculate the surface area generated when the curves, this is the first one, and the second one from t equal to 0 to t equal to pi by 2 rotated about the x-axis. So looking at this, you see that our functions are now parametric equations. Whenever we are dealing with parametric equations, whether it is for surface area or arc length, all we need to do is to know how our formula starts. So you see the rotation is about the x-axis. So we'll simply go to our formula sheet, check a formula that starts with ax, but that formula must end with du. If you are a math and 6 student, you should be checking on your formula sheet, page 7, formula that starts with ax and ends with du. In which case, we'll be changing that du to dt because our value here is t and not u. So I'll go to page 7 of my formula sheet. I'll check the formula that starts with ax because of the x-axis rotation. But that formula is supposed to end with du, where I will replace the u by t since my value is t. So I'm seeing the integral from t1 to t2. I have 2 pi y there, the square root of dx on dt, all the square plus dy on dt, all that square. So that becomes my formula. So whenever we are dealing with parametrics, for surface area, the rotation is what guides us on how our formula starts, because our limits cannot guide us like in other cases. So now that I've picked my formula, the story is the same. My formula must guide me through the whole procedure. So I need to differentiate x with respect to t squared 8, differentiate y with respect to t squared 8, then add the two squares together before I move on. So my x looks quite long. My x is the limit of sec t plus tan t minus sin t. So that is my x. So I'm supposed to take my time and differentiate that. So when I'm differentiating dx on dt, we know that to differentiate lim into another function, we need the chain rule to do this derivative, because lim is a function that is carrying another function. So we must differentiate outside, differentiate inside. So each time I differentiate lim, I must get 1 on the function that lim is carrying, which is 1 on sec t tan t. Then I have to multiply this by the derivative of what is inside. So when we differentiate sec, I believe it is sec tan. Let me just confirm that on page number 2 of my formula sheet. Here the derivative of sec is sec tan. So if I differentiate what is here, I will get sec t tan t. So that's the derivative of sec plus then the derivative of tan. Once I differentiate tan, I get sec squared t. Then minus the derivative of sin t, which gives me it gives me cos t, sorry. So when I differentiate sin t, I get cos t. I'm just confirming that I differentiated lim. It took me to 1 on this item, which is what lim is carrying. When I differentiate sec, my formula says the derivative of sec is sec tan plus the derivative of tan, which is sec squared, and the derivative of sine. We all know the derivative of sine to be cos. So that is so far my derivative. So I'm going to look at that derivative. You see, it looks quite complicated, but with trigonometry, whenever you do your derivative, it's always advisable to try to take out common factors, simplify it, and try to break it down if possible. You go to page 1 of the formula sheet. So when I look at this product, I can see that sec is a common factor in this product. So I'll take out sec as a common factor in the second bracket. So this will give me 1 on sec t plus tan t. That is my first bracket. Then in the second, if I take out sec as a common factor, I will get t plus sec t into sec t, because I've taken out sec as a common factor, then minus cos t. So this will permit tan t plus sec t to cancel one another, so this bracket will take care of that. Then I'm only left with sec t minus cos t as my derivative. So I guess that is what I get as the derivative of x with respect to t. So I've succeeded to do this part. Now the next thing is to square it. So that is my dx on dt. So if I square dx on dt, that means I'm squaring sec t minus cos t. So that is what I'm squaring. And we know our rule that there's no way we can do mathematics without coming across a minus b or that square to give us a square. How do I get a square? I take the first term, square it, I get that. Then the middle term, I take the power times first times second. That will give me negative 2ab. Then the last term will be plus b squared, because when I square negative b gives me a positive. Each time you square a negative number, you get a positive. You square the first, you get a squared. In the middle term, you just take the power times the first times the second. That's how we get it. So from this square, we expect 3 terms. So my 3 terms will be sec square t minus 2 sec t cos t plus cos squared t. So those are my 3 terms. So that's how easy it is. So if I'm moving on now, this was squaring. If I have to move on now, what else do I need? I need now to differentiate y. Let's try to do that here. Our y is cos t. So when you differentiate cos, you get negative sign. And when you square your derivative, it will give you remember, each time I square a negative number, it must always return positive. So that is it. So it will give me my positive. So I have succeeded to differentiate x with respect to t. I've squared it to get my 3 terms down here. I've differentiated y with respect to t. I've squared it to get this. So it's now time to add the 2 together. The formula requests us to do. So I'm now taking dx on dt squared plus dy on dt squared, which means dx dt has 3 terms. If I pull them together, I'll get sec squared t minus 2 sec t cos t plus cos squared t. Then in addition to that, I will bring in dy dt all that square, which itself is sine squared t. So it's now time to simplify. So to simplify, I will see that the last 2 terms are formula number 1, page 1 of my formula sheet. Remember, I always say when you are dealing with trigonometry, there is no way you can run away from page 1. So cos squared plus sine squared is 1. If you're also looking at page number 1, you pick from it that sec is 1 over cos. So that means that item should also cancel. I'm just confirming sec is 1 over cos. So if I were to take my time and figure that out, this will be sec squared t minus 2 times 1 over cos t times cos t. So then plus 1, because cos squared plus sine squared is 1. So here, this takes care of that. Then I have 1 minus 2 is negative 1. So I'm having sec squared t minus 1. So that is what I have. Then I will check from page 1 whether there is a formula that can handle sec squared t minus 1. So on my formula sheet, page number 1, formula number 2, I see from formula number 2 on page 1 that 1 plus tan squared t is sec squared t. So that means if this one crosses over, you will see that tan squared t is what gives us sec squared t minus 1. So you guys see the way I'm busy with my formula sheet whenever I'm dealing with trigonometric functions. So this is just reminding me that what I have here is a simple tan square t. So each time you are dealing with question 6, whatever goes under the square root must be something that the square root can handle with ease. If it is not like that, then you didn't take your time. And if you are dealing with trigonometry, as you see, you must always be around page 1 to look for the right formula to help you out. So I can now go to my integral ax is equal to 2 pi is a constant, and take it out. The integral from t1 will be 0, t2 will be pi over 3. Then y, don't forget your formula has a y, and our variable here is t. So we'll make the meaning of y, and our y is cos. So we'll have cos t times the square root of, under the square root, all these calculations reduce to tan square t. So we'll get tan square t then dt. So this is the simple thing we are now handling here. So that will reduce to 2 pi, the integral from 0 to pi over 3 of cos t multiplied by tan t dt. But we all know that the base of trigonometry is sine and cos. So if I have cos t multiplying tan t, this is the same thing as saying cos t is multiplying sine t on cos t, where cos will cancel. That will leave us with sine t. So it means if you simplify cos t multiplying tan t, it will end up being the integral from 0 to pi over 3 of a simple sine t dt. So that's where it goes. Cos times tan. I've tried to simplify it there. You see it's sine t. So all you need now is to integrate sine t. If you have forgotten, just go to the formula like I'm doing. You look on page 2. That's where the integrals are found. The integral of sine is negative cos. So this will give me negative cos t from 0 to pi over 3. So what is left of us is to substitute our limit. So I will start with my upper limit. So I'll get 2 pi. I can even take out the negative. Since negative is a constant, then I substitute my limit only on cos. So I'm taking out this negative to make pi outside. So I get cos pi over 3. Then minus, then I take 2 pi again, I start the process again, put cos 0. So that is what I have done. Then I go to my calculator and check what does that give me. So cos pi over 3, I'm taking negative 2 pi into cos pi on 3. So that is what I get. That's my upper limit, and there are 2 positives, negatives, then I create a positive, then I take cos 0. Sorry, I didn't take 2 pi, then cos 0. So that is it. The answer must always be positive, so my result is pi, a simple pi. So that's how simple it is, guys. Our answer is a simple pi unit square. Pi is 3,041, somewhere around there. So guys, that's how easy it is to calculate surface area. I hope that helped you out. Thank you very much.